Hey, what's up, folks? How's it going? This is Avijit here, and welcome to Devops Challenge Hub. So let's start with today's interview question. So let me share my screen. So today's interview question is, how do you handle the chicken egg problem with dependencies in cloud formation? Or it can be design a cloud formation architecture for a microservice application with shared resources and service-specific resources. So answer to this both questions will be almost similar. When you are designing cloud formation template, you're creating a cloud formation architecture for microservice based application, then there will be some chicken egg problem like interdependencies. So how do you solve this problem, and what are the best practices you will follow? So it's little for senior role, senior DevOps engineer role, mid to senior level experience. So first we'll discuss what is the chicken egg problem in AWS cloud formation. Let's say like your stack A depends on stack B, and stack B also needs stack A. A depends on B, B depends on A. So that's a chicken egg problem, right? So you cannot start A because it depends on B. You cannot create B because it depends on A. So that is the problem. So one real example is microservice and load balancer. So there is a shared load balancer. Load balancer is where the traffic hits, and then ALB, application load balancer, and based on the route, it will direct to different services. Let's say it's like a traffic control. So there are multiple services: user service, order service, right? Payment service. There can be different services. So your website.com/user service, your website.com/order service, your website.com/ let's say payment service. So based on that route, it will direct to the service. Now, uh, each service, that user service, load service, they want ALB to be there, application load balancer should be there, so that it will be able to connect. But this load balancer also wants them, that service, so that it will be able to create a target group. But the ALB also needs to know about those services target group to route traffic correctly. So it's like a chicken egg problem. ALB stack can't wait for the services, service can't wait for the ALB exist. So A depends on B, B depends on A. So application load balancer, they depend on the service, service stack depend on the application load balancer. So that's a chicken egg problem. So how do we solve this problem in cloud formation stack? So first step is to design layered stack design. You have to design a layered way of designing the stack. First, you create the very basic, the way you create the building, right? First, you create all the basic networking components, VPC, virtual private cloud, subnets, NAT gateways. Once the basic stack you created, then you create the shared resources like application load balancer, listener, default target groups. And finally, in the layer 3, you create microservices where your actual business logic will be done. And for this, how will you break this dependency chicken egg problem? So you create a dummy target group, empty placeholder in ALB stack. In this application load balancer, you create a empty target group, which will add a default listener, which return 404 error. Later, when you create a microservice, in the layer 3, you create a microservice, you will have that real rules, routing rules, target groups, that you will update that stack. Then you can go and update that. Right? So this is the way you will be designing layered approach, and to break the dependency, add a dummy thing in the ALB stack. And then another important part of the design is use export and import. So they are not tightly coupled; they're loosely coupled. So each stack is not dependent on the other stack. Like it can export the value, other stack can import that value. So in ALB stack, you export that shared ALB ARN, and then in the service stack, you just import it. You import it. So that way, they're loosely coupled. They are not tightly coupled like this. They're loosely coupled. This guy export, this guy import that value. And then define a deployment order. Like first stack one should be implemented, that is the basic PPC network. Then the shared resources, second step. Third step is your ECS, that application, your microservice. First step is basic networking, VPC, subnet, etc. security. Second step, your shared resources. Final step is your business logic or microservices. Step 1, step 2, step 3. Stack 1, stack 2, stack 3. These are the deployment order you have to write a small script. You deploy AWS Cloud Information Deploy, template file, network, ALB, user services. So these are 3 steps. So what are the best practices you will follow if someone asks you to what is the design or how will you break this chicken egg problem? Break into layers. First step is break into layers. This if you break into layers, it helps you to avoid a circular dependency. A depends on B, B depends on C. That kind of circular dependency you can avoid. Export import values. So no need to hard code ARN. Export it, import it. No need to hard code ARNs. With ARN, you uniquely identify that resource. And then default listener. So ALB is ready even before the service exists. Add some default one. That way you can dummy default one. You can break it away. Dependency. Use parameter store for configs like DB URLs. Don't hard code in the CloudFormation template. Use parameter store. Health checks. So only healthy ECS task receives traffic. Separate CI/CD pipeline. One for shared infra, other one for microservice, and tag resource for easier billing, etc. Also, any secrets, etc., you put it in, keep it in the secrets manager. Don't hard code in the CloudFormation. So these are the best practices we need to follow, right? So what are the final takeaway? We can break the infrastructure into smaller parts, build small parts, then share using inputs and outputs, use dummy placeholder to avoid dependency loop. Okay. So I hope it's clear answer to this question. How do you break that chicken egg problem? How do you solve that? Or what will be your CloudFormation architecture design? You can listen to it once again so that it's more clear. And after that, you can try to you can practice telling it in your own language. Whatever you heard this, I will ask you to practice it in your own language, as if you are sitting in front of an interviewer and then practice it. Whatever I said, that you can summarize it, think in a picture like a story, and then present it. So let's go to the quiz section. Quiz section. Today's quiz we have: what is the main purpose of separating CloudFormation stacks into foundation, shared services, and service layer? Why we are breaking into 3 things? To reduce the template size. Okay. To follow the principle of least privilege, to promote modular independent deployments, avoid circular dependency. So C is the best one, best answer. To promote modular independent deployment, avoid circular dependency. What problem arises when ALB target groups are created by microservices stacks, but also referenced in shared ALB stacks? So what is the issue? We know that it's a circular dependency error. Answer B. So that's it for today. Hope you like this video. Please like, share, and subscribe to my YouTube channel. Also comment how you are finding these videos, and follow my LinkedIn challenge, DevOps Challenge Hub. I post quiz contest daily, and also follow WhatsApp channel. Subscribe to my WhatsApp channel, DevOps Challenge Hub. I post regular updates. Okay, and I'm also conducting a regular mock live interview, so you will get the updates in that WhatsApp channel. Thank you for watching this video. See you again in the next video.